Hi, this is Jeff Gorey, the Principal Investigator for the Transformer Toolkit project. I am back again with another video tutorial, so let's dive right into it. Today we're going to be going over the Transformer Purchasing Forecasting Guide Summary tab. So this is the big tab that gives us all the results. It's kind of optimized to be viewed half screen while you're referencing something else on the right side, and you can always press this optimize size macro on the top left that'll zoom in to the relevant parts. For now, we'll talk about some of the other macros. On this tab, there is a reroll probabilities macro, and that is, let's pull it up here, Alt window new, and we'll go Alt page down. Sorry. Let's see here. Control page down. So basically, when you hit reroll probabilities, it is going to regenerate your big random number table, and you'll see some of the numbers here changed. So there's that one. Another part of this is we have this like 6-year average table. It's taking all of the simulations that we've done, and it's averaging those averages to create a more representative model. And so these two columns here that are kind of separated from everything else, let's make that green so that it matches our color there. These two columns are basically summing up and averaging these. This one here is kind of an interesting format. It's telling you in the format of transformer size and kVA, and then the average per year that size has failed. And so 10 with 0.17 here, that's because we have one 10 kVA transformer failing out of these 6 simulations. So like if you were to do 1 divided by 6, it's 16.666% or 17%. There. And so it's giving you an average of what's happening during your 6 simulations. And so whenever I re-roll the probabilities, you'll notice it doesn't add that to the averages. I did that intentionally because I want the user of the tool to control when things are added over here. So if I click this add to averages, you'll notice the color is matched to the color of this table. What it's going to do is it's going to copy these first 5 groupings and then paste them one over and then put our new average in here. So to illustrate that point, I'm going to click add to averages, and you'll see everything moved over. I'm going to click it 6 more times so you can see how it moves over. So we'll do it again. You'll see now we have these 2 10s, and eventually you'll see all of these average percentages come to 1 because they're all going to be the same thing. So let's do it 4 more times. 1, 2, 3, 4. And like we said, now it's all 1, right? Because it's averaging, one instance that we've added 6 times to our average table. So that's how that works. The reason I did that is because let's say you hit reroll probabilities, and because this is a probabilistic tool, some of the probabilities are very, very small. You're rolling them maybe hundreds or thousands of times depending on how many transformers you've entered into the input tab. You could get a pretty anomalous result. And that's true to real life too. You never know when you're gonna, play the roulette wheel and land on red 20 times in a row. It's possible. It's not very probable, but it is possible. So if you get a very anomalous result, like you get like 15 transformer failures out of your 80 that you're modeling here one year, it's not going to automatically add that average to your table. So you have the power to say, I don't really like this one. Let's re-roll our probabilities and say, okay, that makes more sense. I'm going to add that to my averages. So that's what's going on there. Recalculate sim averages. I don't remember exactly what that does. Okay, I do remember actually. We'll get into that in a minute. So the other macro button, let's go in order here, that'll make more sense. The other macro button is called Run 6 Simulations. And I'm really proud of this one. This was a cool idea from someone on the project committee that we implemented. Basically, the problem was, so this is your current simulation right here. these two columns. The problem was, it's like, because it's a probabilistic tool, and like we just said before about the roulette wheel, you never know when you're going to get 20 red in a row. It's hard to say that this is really representative of your future reality. And so the solution to that would be to run multiple simulations and get sort of an error bar effect. And so that's what we've done here. If I click this button, and normally before I click this button, I click save here, because it is a pretty rigorous calculation. If you have an older laptop, it may strain it a little bit. It's not going to crash, but what'll happen is it may take a little bit longer for your calculation to run. But let's go ahead and press this and see what happens. The screen is going to be flashing. What it's doing is it's running thousands and thousands of simulations, 6 different times, and then it's averaging those simulations. And so that's what's happened here. You'll notice that all of the numbers have changed in your average table here. And then this column right here, it's saying on average, we're going to have 1.33 transformer failures this year. And, towards the end, as you get more peak demand escalation and more EV adoption, I would expect this number to go up, which is exactly what's happening. But what's cool is it's giving you an average. You can expect, given this many simulations, to have this many failures in this year. We've tested it against real world data, and it's pretty accurate. It's a pretty great way to forecast your future failures. And if you press this again, you're going to get some different results, right? Because it is probabilistic, and you're on that side of the curve where you have many small probabilities, but you'll notice that the trend is the same, exactly like we would expect. I expect this number to go up and be higher towards the end when we've got more, more peak load served, right? Because we have a percentage peak demand escalation that we've incorporated here. And as we have more electric vehicles, right? I would expect this to be the case where we have more failures. And if we were to, go into our assumptions here and say, make a change here so that, let's say the peak demand escalation rate is higher, I would expect there to be more failures. So let's see what happens. Yep, and we get more failures as we get further out on our curve. One thing you'll notice is that as I made that change there from 0.5 to 2, let's make it more drastic, 0.5 to 5. You'll notice that these columns change, but the ones that don't are the average columns. And we did that intentionally because we basically only want the averages to change as you've decided, like, that is the way that I want to go. So if you make changes over here and you want to see what those changes do to your 6 simulation average, you have to run the 6 simulations again. And that may seem arduous and annoying, but if we didn't do it that way, to where the 6 simulations was real time, every time you changed any number in this entire spreadsheet, it would be doing this. It would be flashing the screen. And so, when you do make changes to assumptions, it is going to be real time in these columns, which is your current simulation. And I apologize, you probably hear my cat going to town on the litter box back there. As you make changes to this, the real-time changes are going to happen in these columns, but they're not going to happen here in your averages. And so that is one thing to be aware of, but I think it's pretty evident that is the way to go, given what we just saw there with what happens when you need to model 6 of those. So, I think that's a pretty good representation of the summary tab. I could talk a little bit more about the graphs here. The first graph is just transformer failures, the number of failures that happen on your, and these, I will say these graphs too, just so they're real time, are just the current simulation, not the 6 averages. Yeah, it's showing, your transformers each year as you step through the model from year 1 in the simulation to year 41. It's showing you the peak load served, which we would expect to increase because of our peak load escalation and also our EV adoption rate. It's showing you the EV market share. The blue line here is the modeled number, and the orange line is actual. The reason there's a difference is because it's probabilistic as we want. So it's not going to always perfectly line up. Sometimes it'll be higher. Most of the time it's lower, just the way that it works out. But, I just re-rolled my probabilities there to illustrate that. The base peak load per customer, it's going up here and it's hitting that, what we specified in the assumptions for the ceiling. If we made this like 100, I would expect that to be, higher up ceiling. But yeah, that's another one there. And then this should say total EVs, not total EVs. EVs. These are just, the total electric vehicles on the system. It starts out pretty small here, but that's because in this simulation we say 1.4%. Let's say it's California in a few years where like 25% are on there. You'll see it starts out, at like 25% of whatever the total vehicles we modeled, given our other assumptions are. So that is pretty much it here. Nice tab. It's color coded, like I said, and don't forget about the optimized size macro as you're moving things around here. If you have any questions on this tool, my email should be listed in the descriptions for these videos. On the first tab of the spreadsheet, on the tips tab, there should be a link to this playlist. So let's just go ahead and test to make sure that's working out right. It is. So maybe you get to another part of the tool, you're unsure how to use it. Click that link. Don't forget that's there. Don't forget about these yellow tabs. They're there to help you if anything gets confusing. And that's pretty much it for this video. Thanks for watching, and as always, good luck using the tool.